what you're about to watch now is a simple man's guide, I suppose, to the H2S MkII TR that we've got at the Heritage Centre. But before we watch this, I just want to point out the fact that I'm mentioning voltages and frequencies, and I didn't pull those out my head. They were got from the detailed manual. I'll put a picture of it up here somewhere. And yeah, so I've tried to keep it fairly simple. Although there's not a lot in there, it's quite complex. I would recommend, if you want to know about some of the particular components, Google, Wikipedia. Yeah, you'll be able to learn about it there. So without further ado, over to me. 1, 2, 3. Welcome. We're at the Heritage Centre today, and I'm doing a little bit of filming about some of the bits and pieces that appeared here a couple of weeks ago. What it is, it's a H2S MkII transmitter and associated components. Basically, it's a homebrew. The transmitter's original, some of the components are original, but the rest of it is homebrew. Someone put it together to try and get the transmitter to work. It's obviously, the old boy's been doing it for a while, and it's been passed on to us. Would we like it? Well, I don't think we can get it running, because I don't like sort of playing around with 4 to 14 kilovolts, but it's certainly well worth a look-see to see how in the 1940s, because this is what this dates from, how it was, how they put it together, and how it was the basics of how it runs. It might be, I don't know whether it's going to be a two-parter. Depends on how long it takes to describe everything, because it's quite complex. So, oh, pardon me, I've just had lunch, which was very nice here at the Heritage Centre. So without further ado, let's get on with it. Okay, this might be a little on the shaky side, because guess who forgot his tripod today? So anyway, this is the TR. Okay, it's a H2S MkII. Running on the 10 centimetre waveband. So that's 3 gigahertz or somewhere like that. So this does contain a magnetron. It's got all the original components in it. So what we've got is, on the sockets on the front, we've got the breeze plug, which has all the various voltages and controls input. Let's try and get this right. Looking at the side, that is from the modulator. That's the trigger pulse to fire the magnetron. That is a local oscillator input. This attachment here allows you to tune the soft rumbotron, or TR cell, call it what you will, and also this clamp here clamps in place the destruct charge. So the idea was, this was top secret, above top secret, and in the event of anything happening to the aircraft, if it landed intact, this charge would be set off, which would destroy the components inside. Yeah. Because with magnetrons you can measure the cavity in the magnetron, and that will tell you the frequency it works at. So anyway, so that's where the destructive the charge was mounted. That's the RF output to the second IF stage, and that's the connection to the radar antenna. Okay. So we are 3 centimetre waveband, so we don't need coax. We don't need waveguide, because 10 centimetre waveguide would be rather large, and so the coax goes from here down to the scanner. Okay, so moving around. There's the blower motor, keeps everything cool. The rubber mounts have gone, I've got to fix that. Here's the input from your modulator, or not from the modulator, from your Triggertron. Yes, from the modulator. It's been a long morning already. Okay, that goes into there. So your modulator, this is the homebrew modulator, and it looks like that. Okay, so there you got your Triggertron, okay, which is a gas-filled valve under high pressure, and it's a mega high power switch, if you want to put it that way. When that's triggered, it fires off the pulse to the magnetron, which kicks the magnetron into transmitting. I know the light's not very good, you'll have to forgive me, but yeah. So there's the Triggertron in situ. All you old radar boys who worked on H2S ASV21, Red Steer, certainly Red Steer Mark II, you'll have changed loads of those in your time if you worked in the Bay. Yeah, it was still being used in the 70s, 80s, 90s, yeah, where the old radar kit was. Anyway, slight digression, back to the TR. We'll turn it round. Okay, the back of the TR, okay, let's get the right one, the bottom one, that one there, this one here is that is your Magnetron heater transformer, yeah, which just gets the heaters in because it's a thermionic valve, gets the heaters in the Magnetron nice and warm, so that it's ready to go. We then have keep alive, yeah, so that keeps the Magnetron ticking over, and so that when the pulse is fed through this transformer here, down here to here, to that point there, right, that energizes the magnetron big time. I won't try and describe how a magnetron works, needless to say, it's very complex. Google it, yeah, because they're quite amazing bits of kit. Basically, some people call it a diode in a magnet. So there's a huge magnet, this big grey thing here is the magnet. Your magnetron is this little black dealie here. You fire that off. The thing about a magnetron is that once it gets going, you don't need the heaters. There's enough energy in there to keep it going big time. That's the exhaust for the heat, for the hot air gases. You can imagine this is going to get hot. There's your output down here. You have a tuning slug there, yeah, like there, and then we'll just move round. Move it round. Okay, I think you're possibly seeing there now. Okay, and then that goes down there out the front to the waveguide, not the waveguide, to the antenna, and then you chuck out your 10 kilowatts or whatever it is on these. I can't remember offhand. I might look it up and put it up because I've got the book at home. So yeah, so you chuck your 10 kilowatts down there, and that fires it off somewhere else. Goes to your antenna, and then out to the ground, or if it's an AI radar, you'll be looking for other aircraft in the vicinity. Other things worthy of note here. That's your, get my finger out of the way, there's your return line for your pulses. You'll notice it's coming off the same line as the transmitter. We'll talk about that in a minute. You've got your soft rumbatron there, your detector valve there, and if we get this right, this is a mixer bridge, not a balanced mixer bridge, it's a mixer bridge, and your local oscillator comes in here. So what's going on here, because you can imagine that's a rather delicate little detector diode, and if you're bringing 10 kilowatts down there, you know, what's it doing up this pipe? So I might have to revert to a drawing, so hang on one. Right, we're back again. This should be interesting because I'm doing it one-handed on my whiteboard. Right, so got the magnetron here, it's firing down here, and the RX is down there. Yeah, so this goes both ways. So you can imagine that's coming down there, it's going to see this gap, it's going to shoot off down there, and it's going to go yay, and the little crystal in the mixer bridge is going to go blah. Right, so what we do is we have a spark gap there, basically a spark gap, and it has a keep alive on it, I think of something like 4 kV, something like that on there, something like about 4 kilovolts at that point, and that point of course would be Earth. So magnetron fires, the pulse comes down here, sees this, right, there's enough energy there now to trigger that, so that fires. This then becomes a short circuit, so it can't go down there, so it'll continue back down there. On the return, right, we are talking now microwatts of power coming back, and so it's going to come back. There's not enough power to trigger this, and it heads off down towards the receiver. Very simple. Obviously some boffin thought of it, and it's very clever. The soft Rumbotron itself, let me just, this is what it looks like. Yeah, so you've got your cavity going through it, you can see through it there. You can see the spark gap. It has a keep alive electrode on the top. That's where it's mounted to the frame, and yeah, and it is tunable. All the ones I've worked with in the past have been built into the waveguide. The ones I'm thinking here, the one H2S MkII, pardon me, 3 centimeter waveband, 9 gigs. It was built into the waveguide, and it's a very simple system. Good way of doing it. The more you learn about microwaves, the more you learn how peculiar they behave. So anyway, so here we've got our soft Rumbotron spark gap TR cell, call it what you will. That's coming across here, and there's a little in this block here. Okay, so you've got your 9 gig, you've got your 3 gigahertz coming that way. Yeah. Amplifying 3 gigahertz is going to be really difficult, especially at the power levels we're talking about. So we use an intermediate frequency that we're feeding in there, and that is mixed and detected with this little diode here. And I'll get it out in a minute and show you. And that comes out then down this coax lead, yeah, and out the front to the receiver. With all my excitement, I've forgotten to mention the first stage IF amplification, or as it's called in the book that I've been getting all the details from, the head amplifier. Yeah, and for anyone who's interested, the IF frequency is 13.5 megahertz. So there you go. It goes from the mixer to the head amplifier, and then out to the IF amplifier receiver a bit further up the line. Okay, hope that yeah, simplifies it. So we'll just pop this off here. If I can get that off there. I know it came off the other day. It's a bit of a fiddle. Now on MBS, yeah, we usually change these because you transmit on the ground and the power you're coming back is a bit too much for it. So yeah, so it's a little crystal. Once again, Google it. There's a very good website. I think it's Vintage Valves or something. And obviously, people collect these valves because some of them we're very much a one-off. There we go, that's back in. We're very much a one-off. Talking about the local oscillator on this was run by Klystron. Yeah. Once again, I'm not going to describe it, Google it. It's another microwave device, and here it is. Yeah. That's in its little enclosure. So there's the Klystron. You've got a tune cavity in the middle, so very similar to the Rumbatron. Once again, you're running this to get a high frequency out of it. They are tunable because there's a tuning slug in this. I'll show it with the Rumbatron because it's easy to see. In this metal cavity here, yeah, which is a tune cavity. On your Klystron, there's a tuning slug. You possibly just see me this knob here, if you like. Yeah. And that allows you to precisely tune what frequency comes out of here on that port there. Yeah. So this then would connect to your TR here, and that would give you your intermediate frequency, your IF. Yeah, it's all very clever. I mean, when this rocked up, I was absolutely amazed, because these are like more or less like hen's teeth, I suppose. Very rare, especially complete. So the only thing wrong with it is the anti-bib mounts on the fan have gone, and obviously there's a that connector's been replaced. That's a modern one, possibly been replaced because he wanted something that would something modern that would maybe take the 14 kilovolts or whatever he's stuffing down there. Yeah, so there you go. Yeah, a transmitter type TR3191. Right, well, I hope you all enjoyed that. I hope you found it interesting. It's not very often you come across this kind of thing, especially when it's complete and someone's had it running. I'm most impressed. But anyway, that's it for now from the Heritage Centre. I'll catch you guys later. So take care, enjoy yourselves, stay safe out there, and stop playing with the monkeys, okay? Ta-da for now.